Hello, you're welcome. Okay, so now the topic before us is coordinate geometry. Okay, so now we're going to be looking at the definition of coordinate geometry. Okay, so now what is coordinate geometry? Coordinate geometry is defined as the study of geometry using coordinate system. Okay, right? The study of geometry using coordinate system. Now the question is, what is a coordinate system? Now, a coordinate system uses ordered pair of numbers. Okay, for example, x comma y. These are orders. This is a pair. Okay, x and y. These are numbers. X represent number. Y also represent number. So it's a pair of numbers. So ordered pair of numbers to locate a point on a plane. Okay. So it is regarded as x comma y coordinate. Now to illustrate this, okay, coordinate system is actually what you use, okay, whenever you want to draw a graph, if you have actually drawn a graph before. Okay, now of course, in order for you to actually draw a graph, you have two axes. Okay, the y axis and of course the x axis. All right, so the vertical axis is the y-axis and the horizontal axis is s-axis. So the point of the graph is actually located, okay, at different points, different pairs of value of x and y. For example, okay, let's say I have a point here. Let me call it y1, and of course a point here x1. Okay. So if I want to locate a point that actually corresponds to y1 and s1, all I just need to do is just to trace it, okay, to the point where they intersect. Any point in a graph or in a plane, okay, is made up of the intersection of two coordinates, which of course a pair of coordinates, okay, which of two is a pair. So and the pair is x y, okay, x comma y. So at this point, okay, so this is gonna be x1, then of course comma y1. All right, so anytime you see this, all right, let's say for example 2 comma 3, all right, this is a coordinate, okay, this is a coordinate, right, that you can actually locate in a graph. So let's actually locate this coordinate in a graph. Let's say I have a graph, okay, of course y and x. All right, so let's say this is y is 1 2, okay, 3. Just the way you draw your graph. Okay, so s is 1 2 3. So if I want to locate this point 2 comma 3, the 2 here represent x. The first number in a coordinate, okay, always represent x, while the second number always represent y. Okay, so that means the x here is 2, so I will trace 2, then y is 3. So the point where x, excuse me, okay, the point where the x and the y intersect, okay, that is the coordinate of that particular point. So please take note of that. So this is the coordinate of, so the coordinate of this point, okay, is simply gonna be 2 for the x, okay, then comma 3, which of course is for the y. So that is coordinate systems. I hope you understand that. All right, okay, so now we're gonna continue. We're gonna look at the next subtopic, so very important. Okay, so now we have known what a coordinate is. Okay, so how do we define increment? That's what is known as increment, okay, in a coordinate system. All right, so now let me bring a note on the screen so that we're going to look at it. Increment. Now increment of or change, okay, you can use this. All right, so now this is the difference between the coordinate of 2 points in a plane. Right, so remember, in a plane I can have 2 points. Now the difference between the coordinate of those 2 points is what is known as increment or change, and we represent that. Okay, for the increment in x, I use delta x to represent it. Okay, delta x is what is known as increment in s or change in s. Okay, increment or change in what? X coordinate. So that's what it means. And how do I get the change? Okay, change always occur when there are 2 points, the initial point and final point. Okay, now let's say the initial point is x2. The initial point is of s is s1 and the final point is s2. So change in s is gonna be s2 minus x1. This is a change. Okay, then of course change in y or increment in y. Okay, which of course this represents increment or a change in y coordinate. Okay, so this simply means that change in y is going to be equal to y2, right, minus y1. Okay, so now let's look at a typical example. I'm going to bring some question. Okay, all right, so here we go. Okay, so I'm going to bring some example here. So let's say you have 2 points. As you can see, example, evaluate the x and y increment of the following points. Okay, this is the initial point P1, and this is the initial coordinate of the point and the final coordinate of the point P. All right, so so let's start with increment in x. Remember, the increment in s is x2, all right, minus x1. So s2 here, of course, is found in P2, that's 3, and the s1 is 2. So that's going to give me 3 minus 2, which of course is 1. Okay, as simple as that. Then of course this increment in x, the increment in y, simple, that's going to give me y2 final y minus the initial y, which of course the final y here is 5 and the initial y is 3. So that's going to give me 5 minus 3, which of course is 2. Okay, so B part of the question, let's look at it. Increment in x, the x2 here is 1 and the s1 is minus 1. So that's going to be 1. Okay, s2 minus s1, right? So as you can see here, the s2 is 1, then minus s1. s1 is minus 1, so that's going to be minus into minus 1. And of course, minus into minus 1 gives me 1 plus 1. Okay, that is going to give me 2. Of course, delta y, the final y is minus 2, initial y is minus 3. So I'm going to have minus 3 minus into minus 2. Okay, so what does that give me? Minus 3 plus 2, which gives me minus 1. So that is how we evaluate increment. Okay, now how do we examine increment in a graph? Okay, let me draw the graph. Okay, show you how we represent increment in a graph. So let's say this is a graph. I will have 2 points. Okay, let's say the initial point here is x1 and the final point is x2. Okay, initial point here is y1, final point is y2. So that means the intersection at this point, okay, where s1 and y1 intersect, okay, that's the initial point P1. Okay, the initial point, the coordinate is x1, okay, comma y1. So now at the point where, okay, x2 All right, x2 and y2 intersects. That is the final point. Okay, p2 with coordinate s2. Okay, minus, excuse me, s2 comma, excuse me, s2 comma y2. All right, so you discover there's a change in x from s1 to s2. So I'm going to draw a graph. I'm going to draw a line to join it, to join this point to this point. So I call it delta x. Okay, and there's a change. Okay, from here to here, initial y to the final y. So that gives me delta y. Okay, so this point p1 and p2, I can join it. I can join p1 and p2. All right, so that is how we can represent change. Okay, delta, change in x, as you can see here. This is changing x, and of course this is changing y. All right, so please take note of that. Of course, we are going to, this will actually make sense as we look at the next subtopic. Okay, so what is the next subtopic? Let's go there. All right, the next subtopic, we are going to be looking at distance between 2 points. Now we know that there are, we have 2 points. Okay, so we look at how can we determine the distance between those 2 points, and that's what you're going to be looking at now. Okay, distance between 2 points in a plane. Okay, so let's draw our graph. I always illustrate this with a graph. Okay, with a straight line graph, because basically coordinate geometry, okay, plane coordinate geometry works with a straight line graph. Very important, really very important for you to consider, right? So now let's say this is a line that actually joined 2 points. Right, the very first point here is s1, okay, comma y1. All right, so the second point here, which being p2, is for x2. All right, y2. So we are looking at the distance between this point p1 and p2. How do we get that distance? Right, so let me use d distance from here to here. Okay, distance p1 p2. How do we get that? How can we get that distance? Okay, we get that distance by actually looking at both the s increment and the y increment. Okay, that's exactly what you're going to do. Now let's look at, of course, if I should trace this is this at this point, this is my s2 already, you know that. Okay, this is my s2. All right, if I should trace it down here, okay, this is sure going to give me my s1, of course. So we simply mean that the distance from here to this point becomes my change in x. Now the same goes for when I trace this is my y1. Okay, so if I trace this, okay, in a straight line, please pardon the graph. Okay, I'll just write it there. This is my y2. Okay, so that means the distance from here to here becomes delta y. Okay, y2 to y1. Okay, so you discover that by actually, okay, extending the change for x and change for y, okay, about this line, you discover that I have actually constructed a right angle triangle. Of course, this is a right angle triangle, right? Okay, in which the distance I'm looking for, b, is the hypotenuse. Are you okay? The delta s is the adjacent, and of course delta y is opposite. So for me to find, remember in Pythagoras theorem, you can always find the distance of the hypotenuse. Okay, so applying Pythagoras theorem, the distance of the hypotenuse, which of course the p1 to p2, all right, dp1 to p2 is going to be equal to, if you can still remember Pythagoras theorem, okay, horizontal square or adjacent square, that is changing x square, all right, plus changing y square. All right, okay, so of course let's actually evaluate this now. This is going to be, our change, that x, our changing s. Okay, of course that's going to is always x2 minus x1 all square, then plus y2 minus y1 all square. All square, okay? So as easy as that. So anytime you are being asked to find distance between 2 points in a plane, this is the formula. Very simple and very, very, very precise, okay? So let's apply this, okay? Let's solve an example. Let's solve an example. Definitely we're going to solve an example, okay? So I bring some question on this screen. Here we go. Okay, so bring it here. Okay, so this goes like this. Okay, what is the distance between, okay, they have this A part of the question, between A and B. Okay, so this is coordinate of A and the coordinate of B. So distance between A comma B, of course applying our formula, don't forget, okay, is the square root of delta x, okay, which of course is x2 minus x1, right, all square, then plus delta y, y2 minus y1 all square. Okay, guys, let's go there. So we'll put our values. So for my S2, okay, is found in B, that's 2. S2 is 2, and of course S1 is 1. So that's gonna give me 2 minus 1 all square, then plus y2, okay, that's minus 4, y1 is minus 3, so that's gonna give me minus 4 minus into minus 3, right? Okay, all square. All right, so let's go there. Here we go. 2 minus 1 is 1, that's 1 square, right? Then this is going to be equal to minus, of course, minus here is plus, minus times minus is plus, so I'm having minus 4 plus 3, okay, that's still going to give me minus 1 all square. All right, so this is going to be equal to 1, right, plus 1, minus 1 square is 1, okay, please take note, minus 1 square is 1. All right, so this is square root of 2. So the answer to this is square root of 2. Let's do justice to the B part of the question, okay? So we're looking for distance between C and D. That is the B part of the question. All right, so I believe that you can do this, okay? Just do this yourself. This is very easy with what I've explained so far, okay? To do the next will not going to be a problem. Okay, so let's proceed. This is distance between 2 points in a plane coordinate. Okay, I hope we are good. Let's get to the next subtopic. So we're going to be looking at gradient, I believe, if that's okay. So we are going to look at midpoint. Okay, midpoint of a line. Okay, so do I need to, okay, let me just clean up. So now, having known the distance between 2 points, okay, we'll look at the midpoint, the coordinate of the midpoint. Coordinate. Okay, or let's do this way. Let's look at the coordinate of a point that divides a line. Okay, that is divides a line. Either it divides the line into 2 equal parts or 2 unequal parts. Okay, so let me actually explain what I mean here. Here we go. Okay, coordinate of a point that divides a line. Okay, I'm gonna draw my graph again. Okay, I'm gonna draw a line, a straight line ground line. Okay, of the. All right. So let's say this is actually 2 points. Okay, P1, which of course is S1, Y1. Okay. Then the final point here is P2. Okay, we have X2. All right, Y2. Okay, so this is the initial point, is the final point. But what if we want to locate a point in between? Okay, a point that divides this line into 2 parts, either equal or unequal parts. Okay, so now let's say we want to locate a point. Okay, what will I call it? Let's say point Q that divide this line into 2 ratio. Okay, into, let's say, M is to N ratio. Okay, how do we get this point? How do you get the coordinate of this point? Okay, so that's what we are going to be looking at. So you discover that if this point, okay, is unequal, all right, we can always one part can be greater than the other, all right. But if the 2 parts are equal, that means the ratio of M and N is equal. It can be is 1:1. Okay, so that means if these 2 parts M and N, okay, if this M and N are equal, that means this Q becomes the midpoint. Okay, the midpoint of the line. All right, so at that point it becomes the formula for the midpoint, coordinate of the midpoint of a line. But if it's not equal, okay, the formula actually changes. So let's actually look at a situation where it is not equal. Okay, where the ratio that actually divides the line is M is to N. Okay, so how can I get the coordinate of S coordinate and Y coordinate? Okay, so that means Q now we have a coordinate. Look at how the coordinate we remember in ratio. Okay, if I want to get the ratio of the initial, this is M is the initial, N is the final. Okay, if I want to get the ratio of the initial, that's going to be M, okay, divided by the total ratio, that's M plus N. And of course, if I want to get the ratio of the final, okay, the final is N, still divided by the total ratio, M plus N. Okay, so in terms of coordinates, okay, this point now Q is going to have a coordinate of M x1, okay, plus N s2. Please take note of that. Okay, then divided by their sum M plus N. All right, because S1 is initial, so I multiply by the initial ratio. S2 is the final ratio, is final coordinate of X. Okay, I multiply by the final ratio. So that's how it works. All right, this is for the whole of this now is for just the S, the midpoint for the S coordinates. Okay, I use this one to get the S coordinate. Then comma for the Y, the same thing goes for the Y. Okay, that's going to be M multiplied by Y1. All right, then plus N, all right, multiply by Y2, then divided by their sum. Okay, so that is how we get the coordinate of this point Q that divides this line. Okay, so which simply means that a situation where we're looking at the midpoint, okay, the coordinate of the midpoint, let's say Q is a midpoint. So that means a situation, okay, that means M is to N becomes equal. So the ratio becomes 1:1. So M is to N becomes 1:1, okay? So if we should put that into this formula now, you now discover that, okay, this is going to be equal to the midpoint Q is going to be giving us M, which of course is 1, okay, x1, right? Plus 1s1, okay, please pardon me, 1s1, right, which of course is s1, plus 1x2 then divided by the sum, okay, m plus n, okay, that's 1 plus 1, comma, the same thing for y, okay, 1y1 plus 1y2 divided by 1 plus 1. So that is why for midpoint, let's evaluate this now. So midpoint, the coordinate, okay, the coordinate will becomes s1, okay, is something as s1, 1 plus s2, okay, then divided by 1 plus 1, which is 2. Okay, done. Then this happens going to be y1 plus y2 all over 2. So if what we are dealing with is midpoint, okay, this formula works. But if it is not midpoint, it's a ratio, okay, so we apply this. I hope that is well understood. Okay, let's actually just write this down. It will help you. Let's look at if you have a question, right? Let's get some question. I believe we have some question. Okay. Okay, here we go. Here we go. Okay, here we have some questions. Solution. So the question, what is the coordinate of the midpoint of the line? Okay, P and Q. Okay, so let me use M. Let M, okay, or let me use something else. Let me use let R, okay. Let R, okay, be the midpoint. All right, so that means the coordinate of R now, open bracket, remember the formula, okay, S1 plus S2 divided by 2, comma, Y1 plus Y2 divided by 2. All right, so R now, what's my S1 here? S1 is 1 plus X2 3 divided by 2, comma, what's my Y1 for? My Y1 is 2, then plus Y2, which is 4, then divided by 2. Okay, so I don't know how we have a coordinate of 4 all over 2, that is 2, comma, this is going to be 6 all over 2. So as simple as that. Okay, let's say the ratio. Let's say this question now. Let me bring this, let me introduce ratio here. Let's say this is not the midpoint, okay? Let's say what's the coordinate of the points of the, okay, let me cancel midpoint. Point of the line, okay? Point of line that, okay, let's say with ratio. I don't know how we put the English, but I just want to introduce something here. Okay, let's say with ratio 2:1. Okay, if that is being the case, now that means in that case R is going to be equal to, remember how it is, okay, R is going to be equal to, that means this is M, this is N, remember, okay, so that the formula is mx1 plus nx2, then m plus n, comma, my1 plus ny2 divided by m plus n. Okay, so this is gonna be, here we go, m is 2, right? 2, right? So it's gonna be 2x1 plus 1s2, okay? 1 times s2 is still s2, okay, divided by 2 plus 1, that's 3, comma. All right, what do we have? Okay, All right, so the same thing here. Okay, so gonna be 2y1 plus 1y2. So putting the value now, let's put the value. So what is s1? My s1, okay, from this, my s1 is 1, right? So that's gonna be 2 times 1, 2, plus okay, 3 divided by 3, right? Comma, what was, okay, my y2, my y1 is 2, okay? That is 2 times 2 here, that's gonna be 4. 2 times 2, 4, then plus y2, which is 4, all right? Hope I'm not mistaken, okay? Yeah, y2 is 4. All over 3. Okay, so this is gonna 2 plus 3 is 5. That's gonna be 5 all over 3 bracket 8 comma 8 all over 3. Okay, so that is how that works. Please take note of that, take note of that, take note of that as we proceed. Okay, what do we do next? So we are gonna be talking about gradients. Okay, we'll talk about gradients. So I hope you're good. Okay, I'll clean up. All right, so gradient, that's what we are doing next. Okay, now gradient has the symbol m. Okay, so in coordinate geometry we use m to represent gradient, so please take note of that. All right, so now gradient is actually defined as the slope of a line. So it is also, so the gradient of a line, okay, is something as the slope of the line. All right, and apart from it being the slope of a line, it can also be defined as the inclination of the line. Okay, of course you know what inclination is. Okay, how slopey a line inclined is something. So a line is inclined when it has an angle with the horizontal. Okay, of course you know that graph drawn, all right, in a Cartesian coordinates. In a Cartesian coordinates, okay, a straight line graph is always inclined. Okay, this is how it is. So it shows that when a line is bending, okay, it's inclined. So it can can be of different angles. Okay, and remember vertical is not inclined. Okay, horizontal is not an inclination, but once it is in between, okay, it's an inclination depending on the angle of inclination. So inclination is something as slope, and of course something as gradient. So how do we actually get inclination? Okay, let's discover. Let's see how we can get inclination. Now we have the initial point P1, okay, which of course is S1 comma Y1, right? And we'll have the final point P2, which is S2, right? Y2. So discover that the change we have here, you know our change now. If we should trace our change from here to here is changing x, okay, horizontally, and from here to here is a change in y. Okay, so let me use okay, so invariably now this is changing s, which of course you know from this point to this point is incrementing s, which you know that s increases from s1 to s2, you know that already. Okay, and of course y increases from y1 to y2, right? So from this point to this point is the increment of y, right? So now the inclination is the angle theta. So inclination is something as the angle, the tan of the angle. Please take note. Okay, inclination slope is this is same thing as the tan of the angle of inclination of that particular line, because it's making an angle. Okay, and of course, you know, in trigonometry, tan theta is always given as opposite to, okay, opposite all over adjacent, right? Don't forget SOHCAHTOA. If you have forgotten your ratio, always remember this abbreviation, SOHCAHTOA. So which simply means that tan is always opposite all over adjacent. Okay, so the opposite of this right angle triangle, of course, is the change in y, and the adjacent is change in x. Okay, so which simply means that slope being equal to tan theta, okay, is equal to change in y over change in s. Okay, so we said this is the symbol, right? Is change in y, and of course the change in y, increment in y is always y2 minus y1, right? Then divided by x2 minus x1. Okay, so that have actually handled our problem, and we are good. I believe so. Okay, so this is the formula for slope or gradient. Okay, so please take note of that. Let's see if there are some questions, and we'll do justice to them. Okay, so I'm gonna bring some question on the screen. Okay, so here we go. So let me complete the question. Okay, so we move. Okay, so this goes like this. What is the gradient of the straight line having the following coordinates? So AB with this coordinate and that, and of course C. So we are looking for the slope. Okay, solution. Okay, so a part of the questions. Remember, symbol for slope is m, right? Of course, change in y2 minus y1, right? All over x2 minus x1. Okay, so this is going to be equal to y2 here is minus 4 minus y1 minus 3. Okay, s2 here is 2, and of course s1 is 1. So this is going to be equal to minus, is going to be minus 4 plus 3, which of course is minus 1, divided by 1. Okay, so the slope is minus 1. Hope that is well understood. Okay, B part of the question. Okay, slope y2 minus y1 all over s2 minus x1. Okay, as simple as what we actually did before, which of course the y2 is 5, y1 is 4, right? So it's going to be 5 minus 4, then divided by s2 is minus 1, minus 3. Okay, so of course this is going to be 1 minus 1 minus 3, that's going to give me minus 4, right? So my answer is minus 1 all over 4. As simple as that. I hope we are good. Okay, let's move. Next subtopic. Now we're going to look at relationship. Okay, let's say a situation where you have okay, let's say a situation where you have more than one line in a graph. Relationship between slope of lines. Okay, more than one line in a graph. Okay, so let me draw a graph so that you understand what I mean. Okay, let me draw. Okay, so what I'm looking at here is relationship. Okay, excuse me, relationship between slope. Okay, relationship between slope, okay, of straight lines, of lines, okay. All right, so let's just be okay. So now let's say a situation now where I just want to draw. I want to illustrate something. You have two lines, okay, okay. You have two lines in a graph, okay, and the two lines are parallel to each other, okay. So I'm looking at a situation where you have parallel lines, okay. Now, of course, you know that for parallel lines, okay, they have the same inclination. That is true. When lines are parallel, they have the same what inclination. Their inclination is same. So if this is theta, this will also be theta if they are parallel. So if the slope of this one is m1, okay, and the slope of this is m2, the two slope. So in a graph, okay, when in a coordinate system, when lines are parallel, they have equal slope, okay. So that means if the slope of one is m1 is equal to the slope of m2. So please take note. So this is for parallel lines. Okay, I'm just gonna look at just two lines, okay, parallel lines. But if the lines are perpendicular lines, okay, all right, if the lines are perpendicular lines, their slope is not equal, but is reciprocal, negative reciprocal of each other. So we simply mean that for m1 is always going to be equal to minus the reciprocal, that's 1 all over m2. Okay, so I just want to give you these two relationships for parallel lines and of course perpendicular lines. So please take note because it's going to be of immense importance, okay, as we proceed in this tutorial. It's going to be very, very important. All right. Okay, so now let's now go to the next subtopic, which of course is the equation of a straight line, okay. Okay, so and this part is really very important, all right, so you have to take note of it. So I will just clean up so that we go through this. Okay, equation of a straight line. Okay, so now the equation of a straight line can be evaluated using the following method. So there are different, okay, method of evaluating equation, okay. One of the method, okay, is going to be slope, a method known as slope intercept method. Use this one. Slope intercept method. Okay, so now this is one method, okay, this is one method. Then we are going to look at another method, okay, another method, okay, apart from the slope intercept method, we have another method known as okay, we have slope. Okay, please pardon me. Okay, let me not mix it up. The first method, okay, is point slope method, point and a slope. Okay, then you now have the second, which being slope intercept. Okay, I want to take it this way, slope intercepts. Okay, then the third is gonna be double intercept. Okay, so we're gonna be using these three. Double intercept. All right, so now first of all, what's the equation of a straight line? Okay, that graph that actually give rise to that particular straight line, okay, is actually what gave rise to it is an equation. Okay, remember, when you want to draw a graph, is a straight line graph, you'll be given an equation. Okay, where you'll be given something like y is equal to 2x, example 2x plus 1. Okay, where you say, okay, if x is equal to 1, then what is y? You put s. So after getting your table of value, then you now draw the graph. Yes, this is the equation that give rise to that particular straight line. Okay, so we are going to look at how we derive the equation of a line. So once you are being given some parameters, the coordinates and some other information of that line, can you actually derive the equation? So we are starting with this one, point, okay, slope method. Okay, point slope method. So now point slope method, we are going to start with it. So point slope method means that in this method we are going to apply slope and a point. Okay, so I'm going to give you the formula. The formula is y is equal to m x minus x1, okay, then plus y1. This is a direct formula. Okay, just apply this formula. This formula is for a point slope method of evaluating equation of a straight line. Okay, you know what the m represents. Now you know that the m represents what? The slope. All right, so the point is the coordinate of that's x1. The point where that line is actually passing from or is coming from, that's s1 y1. All right, then as for the s and y, every equation always have the variable y and x. Okay, so this is the variable, the independent and independent variable. Okay, while the one of x1 and y1 is the point through which that line is passing from. Okay, so this m is the slope, y1 x1 is the point. So that means anytime you are being given a point and a slope, we can actually find the equation of a line. Let's see if we have an example, okay, that we could. The example will explain better. All right, so here I have a question here. So let's go there. Okay, so I'll bring it to the screen. Okay, so let me bring it down. All right, so here we go. So the question goes like this: what is the equation of a straight line, okay, of gradients? So the gradients, okay, which of is 3, passing through the points. So the points, okay, the point, which is what? 2, 3. Okay, so that simply means that for the point as s1 there is 2, right, and of course y1 is 3. So we're going to apply our formula. Okay, point slope method. Y is equal to m, right, open bracket, x minus x1, okay, then plus y1. So let's put the value. So that's going to be y is going to be equal to m being the point, that is 3, open bracket, x, all right, s, y and s will always be there, then minus s1. S1 here is 2, Okay, then plus y 1, which is 3. Okay, so let's open this. 3 times x will give me 3x. 3 times minus 2 give me minus 6 plus 3, right? So we evaluate minus 3 plus 6, that's plus 3, minus 3. Okay, so you can bring everything to one side. You can just bring everything y, bring this minus 3x, bring this plus 3 if you wish. Okay, or you can leave it this way, still the same thing. All right, so that's how we evaluate equation using point slope method. So let's look at slope intercept method. In fact, this other method is the standard method for equation of a straight line. Standard. Anytime you are asked what is the standard method of equation of a straight line, that is always okay, slope intercept. Okay, slope intercept method. So in slope intercept method, you need okay, a slope, which of course is the slope. Okay, and you need what? Intercept. The intercept you need is y-intercept. Y-intercept is the point where that particular line is passing through the y-axis. Okay, y-intercept, which of course we use c to represent. Okay, so the general formula, the formula for slope intercept method is y is equal to mx plus c. Okay, m is the slope already, c is the intercept. Okay, so please take note of that. So this is really standard. So anytime you are being asked to convert any expression into a standard equation, okay, it's always in a slope intercept method, right? Okay, let's see if there is a question that we need to. Okay, there is none. Okay, so now we can now work on double intercept. Now let's look at double intercept. Then before we now go to questions, right? Of course, as the name implied, that particular line has double intercept. A double intercept is an intercept that actually cuts both the x and the y axis, as you can see. Okay, so this method is used when the line have two intercept x and y. So this is the y axis, right? And this is the x axis. Okay, so the point, the y-intercept is b, all right, and the s-intercept is a. So this is the formula: x divided by the s-intercept, which is a, plus y divided by the y-intercept, which is b, is always equal to 1. Okay, I hope that's one of this is the formula. Please write this formula down. Let's see, that should be an example. Let's look at an example. Okay, now the question you ask is, how do we even know from a coordinate, how do we know y-intercept, okay, or s-intercept? Please take note of this. I want to bring this to your notice. Okay, at point where s has intercept, okay, okay, let's draw the graph. At the very point where x, okay, has intercept, let's say you have a line, okay, excuse me, okay, as you can see, at that very point where y is having intercept, okay, which is b, s is always 0. Okay, at y-intercept, okay, s is what? 0. So that means if I want to write the coordinate of this point, okay, the coordinate of this point is going to be 0, comma b. So this shows what? S-intercept, okay, because y there is b and s there is 0. Okay, at this point, at the point of x-intercept, okay, s-intercept, definitely y at that point is always equal to 0, and that's what you see here. Okay, s-intercept here is a, right, and y, if you test it, y is what? 0. Y is 0. Okay, so the coordinate at this point, is definitely going to be, okay, S is A, right? Then, so anytime you see a coordinate where, okay, one is 0, the other one is not, okay, that's an intercept point. So now that's just what you're going to be looking at, okay, this question. So now, which simply means that, okay, so let me bring it down. Okay, so in this question now, what is the equation of the line? Okay, P1, from the question P1, S there is 0, right? Y is 1. So that is the S-intercept. P2, okay, 2, 0, Y-intercept. So in this case now, I can simply say that B, being the Y-intercept is 1, right, comma, X is equal to 2. All right, so applying our general equation, remember the equation is always S all over A plus Y all over B is equal to 1. So let's do this. X, okay, this A, please pardon me. S all over A there is 2 plus Y all over B, which is 1, is equal to 1. Okay, so you can use LCM if you wish to. The LCM is 2. 2 divided by 2 is 1. 1 times S will give me X plus 2 divided by 1 is 2. 2 times Y will give me 2Y. Alright, equal to 1. Or better still, you can make it easier, okay, instead of going through all the, okay, multiply everything for you to eliminate the fraction, okay, multiply through, okay, by, okay, the LCM of what? The denominator. Of course, the LCM of this denominator is 2, so I multiply everything by, so that's going to be 2 into, okay, X all over 2, right, plus 2 into Y, of course, all over 1, equal to 2 times 1, 2. So 2 divided 2, you have what? X, then of course plus, excuse me, plus 2Y, right, equal to 2. So we can rearrange the equation and just 2Y plus S, right, bring 2 to the other side. That's, so that is the whole idea. That is the whole idea. So please take note of this. Take note of that as we proceed. All right. So that's something we're gonna do now before we now enter into solution of questions, right? Okay, I think we are going to solve questions. So I'll be bringing questions now on the screen so that we do justice to them. Now, before I solve this question, there's something I wanted to, okay, there's something I wanted to bring. Okay, yeah, this is a subtopic that's, okay, so yeah, this is what I wanted we're supposed to do before we continue, before we solve questions, right? So let's look at how we can actually obtain gradient and intercept from an equation. Okay, Remember, point intercept method or slope intercept method, pardon me, okay, is y is ms plus c. So which simply means that if I have this equation, if I have an equation, okay, in this form, I can always obtain the gradient and intercept. Yes, for me to obtain the gradient, okay, the gradient is simply m, okay, which of course is the coefficient of x. So that means if I have that equation in this format, to get the gradient is easy, just for me to, okay, that will be the coefficient, whatever is the coefficient of x, that is the gradient, okay, and of course the intercept becomes c, okay, and that intercept is just the constant, okay, the constant value in that equation. But I can only obtain this, can only be possible if that equation is of this form. If that equation is not of this form, it is not possible. So which simply means that for me to get the extract, okay, gradient or intercept from an equation, I must always convert it into the standard form, okay, which of course is the slope intercept method. Okay, for example, now I'm going to bring example so that you understand what I mean. Okay, here we go. So what simply means that if I am being given something like this, okay, this question, okay, I'm being asked to, given the equation of a straight line to be 3x, okay, plus 2y minus 1 equal to 0, and from this equation I'm being asked to find the slope and the intercept, of course, which is the vertical intercept. Okay, I can't just say the intercept is 3, no, because I have not converted it to y equal to ms plus c. So for me, I have to convert it. How do I convert it? Just to make y the subject. Remember, okay, in the equation, y ms plus c, y is the subject, so I have to make y the subject here. So how do I do that? Very simple, okay? So that's going to be 2y. I take all this to the other side of the equation. That's going to give me minus 3x. Take this to the other side. Take minus 1 to the other side, becomes plus 1. All right, so this is going to give me y now is going to be equal to, of course, you know that's going to be minus 3x, okay, plus 1, all divided by 2, okay. So I can now split the division. This 2 is dividing this, so I can split it. Okay, that's going to be equal to minus 3x divided by 2, then of course plus 1 all over 2. So as you can see now, comparing this, okay, this equation is of this form, okay, where the m now is the coefficient of x. So in this case now, the m being the slope is minus 3 all over 2, and the intercept c is 1 over 2. Okay, so please take note of this. Okay, so this will help you to always evaluate question that has to do with equations. Okay, so now let's now go to our original question. Here we are. So the question goes like this: what is the equation of a line that passes through the point 2, 3 and it is perpendicular to this line? Okay, is perpendicular to this line. How do we do that? Okay, let's see how we do that. So if this line is passing through this point, okay, it's passing through a point, I'm going to use point, okay, I'm going to use point slope method, okay, which of course, remember, that's going to be mx, okay, minus x1, then plus y1. Okay, so now the point we already know, x1 is 2, y1 is 3. Okay, x1 is 2, y1 is 3. But what we don't know is the slope. Okay, so how do we get this slope? we get the slope by this information that was given, that this particular line that we are actually considering is perpendicular to this line. And of course, if a line is perpendicular, I told you, okay, the slope of m1 is always equal to minus 1 over m2. So all I just need to do is to get the slope of this line, okay? Then I apply this formula, okay? I hope that's well understood. Right, let me clean up. Okay, so now here we go. So I need to get slope from this line that's perpendicular. So I have to convert this line to a point, a slope intercept method. Of course, you know what to do. Okay, so that line is going to be y equal to, take the minus 3x. I think we've done that before. Okay, minus 3x plus 1, right? Of course, divided by 2, right? Which of course gives me minus 3x. Minus 3 over 2x, right? Plus 1 over 2. Which of course we now know that the m, all right, let me call it m1, is 1 over 2. So assuming now this is m2, okay? The slope of this line, and we're told that this line is perpendicular to this line. So if I want to get the slope of this line, now let me call it m2. Remember the formula, okay? M2 is always equal to minus 1 all over, okay, let me call this one m2. That's the second line, okay? Now the line I'm considering, let me call it m1. But it doesn't matter though, okay? You can just call it anything. So m1 is going to be minus 1 over m2, reciprocal. So that's going to be minus into reciprocal, okay, is simply, what am I doing here? Okay, please pardon this. This m2 is minus 3 over 2. Please pardon this mistake, correct? So the reciprocal, okay, m1 now is going to be the reciprocal of this slope. That means 2 will go up. Minus, that's going to be minus 2 all over 3, okay? And of course, minus times minus will give me plus. That's going to be 2 all over 3. So I hope that is well understood. 2 all over 3. So that is this slope that is missing here. I've gotten it is 2 all over 3. So I can now find the equation. So therefore, the equation of the line now okay, therefore it's going to be equal to y, of course, you know, okay, slope m, which of course is 2 all over 3, open bracket, x minus x1, okay, of course the point s1 is 2, y1 is 3, s1 2, then plus y1, which is 3. Of course, you know what we do now. I want to eliminate this, the fraction. I multiply everything by the LCM, okay, which is 3. So that's going to be 3y multiplied by equal to 3 times 2 all over 3 x minus 2, then plus whatever. I multiply everything, okay, the same 3 times 3, right? So this 3 cancels 3. So I now have that 3y is gonna be equal to, open this bracket, 2 times s will give me 2s, right? 2 times minus 2 gives me minus 4, then plus 3 times 3, right? That's 9. Okay, what do we have? So that's gonna be minus 4 plus 9, okay? That should give me plus 5, right? Okay, yeah. So this is gonna be 3y. So I can move everything to this side now. Minus 2x, of course this plus 5 goes over, that's minus 5 equal to 0, okay? So this is the equation. So I hope that is well understood. Okay, so I'm gonna give you a break now. This is just very simple, okay? Just understand the principle behind it, and you will definitely, okay, you will solve any question that is given to you. All right, so just go through it one more time, then as we come back we're going to proceed, okay, with more questions. All right, see you in the next video. Thank you very much. Well, you're welcome back. All right, we're going to continue from where we stop. Okay, so in this tutorial we're going to be looking at the coordinate of the point of intercept of two lines, right, in the Cartesian coordinates. And after this, we're going to be looking at questions. We're going to solve a whole lot of questions. Okay, so just to wrap up coordinate geometry. So now, to find the coordinate of point of intercept of two lines, we solve the equation of the two lines simultaneously. Okay, let's say you got two lines. Okay, one line goes this way, and that line goes this way. Okay, so the intercept at this point P. Okay, with coordinate x comma y. So how will you get this point of intercept? So remember, this line has an equation, this line has an equation. So to get this point of intercept of two lines, you always solve the equation of the two lines simultaneously. And of course, I believe you know how to solve simultaneous equation, right? Okay, so I have an example here. It goes this way. What is the coordinate of the point of intercept of, okay, the first line, x plus y equal to 3. All right, that's the first line. I'll call that equation 1. And of course, the second line, 2y, okay, minus x equal to 5. Okay, so to get x and y, I can simply solve this simultaneously, right? So I can use substitution method. Okay, so from equation 1, I can simply substitute. Okay, from equation 1, I have x. If I make x the subject of formula, x is going to be equal to 3 minus y. Okay, so I'm now going to substitute. So I've gotten x in equation 1, so I have to substitute the value of the x. So as I substitute x equal to 3 minus y, okay, into, I got this from equation 1, so I have to substitute it into equation 2, all right, into equation 2. So now I got equation 2. Equation 2 is 2y. Any place I see x, I put 3 minus y, right? I have to put that in a bracket because this is minus and this minus belongs to x, and x is 3 minus y. So x is the whole of this. I have to put this in a bracket, all right? So please take note of that. Bracket is really very important when you're solving questions. So we're gonna do this. Minus into 3, minus into minus y, that gives me plus y, right? Equal to 5. So if I should add this, that gives me 3y, right? And of course, this goes over, that's going to be 5 plus 3, right? So y now is going to be equal to 5 plus 3 is 8. That's going to be 8, then divided by this 3. Right, so 8 divided by 3, okay, if I'm not mistaken. Yep, 8 divided by 3. Okay, so you can just keep it in a fraction, so which of course is something as how many whole number? That should be 2 whole number. Okay, 2 all over 3. Okay, so for y, for x, this y for now x. Okay, so I'm gonna substitute this into, it's gonna be 3 minus y. Okay, from, that's what we got from equation 1, right? Since we've gotten the y, which of course is 8 minus 3. So x now gonna be 3 minus 8 minus 3, right? We'll solve this. LCM is 3. Okay, this all over 1. 3 divided by 1 is 3. 3 times 3 is 9. 3 divided by 3 is 1. 1 times 8. So 9 minus 8 is 1. So x is 1 all over 3. So just as simple as that. Okay, so that's how you find the coordinate of the point that, okay, of a point of intersect of two lines. So please take note of that. All right, let's look at miscellaneous questions. Okay, I'm gonna solve 2 or 3 questions, okay, just to get this over with. So I have a question here. Let's see. Okay. Okay, I'm looking at a question. Okay, here we go. Okay. Because see, in the figure above, what is the equation of the line that passes through y as it as 0, 5 and of course 5, 0. So remember double intercept, right? The equation is x all over a plus y all over y-intercept is equal to 1, right? So x divided by the s-intercept, the s-intercept is just size 5, okay? Then plus y all over y-intercept, okay? So this y-intercept, db, b is, that's 5, okay? Is equal to 1. Of course, you know what we do, okay? So we multiply through by the LCM of the denominator. The LCM, LCM of this denominator is 5, so that's going to be 5 times x all over 5, right? Plus 5 times, okay? 5 times x, okay? Well, I can just 5 times x, all of 5 times y, please, pardon me. 5 times y all over 5 is equal to 5 times 1. Of course, 5 cancels 5, 5 cancels 5. So the equation now becomes x plus y is equal to 5 times 1 is 5, okay? So, or x plus y minus 5 equal to 0. Okay, so that's it. All right, let's look for another question. Okay, this simple though. Okay, let's do justice to this. Okay, so here we go. All right, this is gonna be midpoint, okay? So of course, you know, for midpoint, okay, so you know our formula, okay? Let's say the midpoint is r. So that's going to, it's always x1 plus x2, right? Divided by 2, this for midpoint, right? Then y1 plus y2. This is the coordinate of the midpoint. So let's go there. S1, okay, so what's my S1? S1 is minus 5, right? Minus 5, excuse me. So S1 here is minus 5, then of course plus minus 3. So minus 5 minus 3 divided by 2. Then y1 is minus 2. Then plus 4 divided by 2. Okay, so let's go there. So this minus 5 minus 3, that's minus 8. And minus 8 divided by 2, that's going to give me minus 4. Come on. Minus 2 plus 4, that's 2. 2 divided by 2, that's 1. So that's the coordinate of the midpoint, okay? Minus 4, comma 1. So this, the C is the right option for that question. Let's proceed. Okay. So I hope you can see the question very well. So it goes like this. Find the equation of the line through the point minus 2, comma 1. So the point is passing through the point. So we simply mean that S1 is minus 2, and of course Y1 is 1. Okay? Alright, and minus 1 over 2, comma 4. That's S2, right? S2 is minus 1 over 2. And okay, y2 is 4. Okay, so we can use slope, okay, point slope method, right? X minus x1, okay, then plus y1. Okay, now the problem is this: we don't have we have our point s1 and y1 have our points, but we don't have our slope. So let's get our slope. So you know how we get our slope, okay? Change in y all over change in x, okay, which of course is y2 minus y1 all over x2 minus x1. All right, so if that being the case, y2 is 4 minus y1 1, x2 is minus half minus x1 into minus 2. Okay, let's go there. So 4 minus 1 is 3. I'm now having minus half, right? Plus minus times minus is plus, plus 2. It's gonna give 3 into, you know what, we simplify. LCM is 2. Okay, of course this one all over 1. 2 divided by 2 is 1. 1 times minus 1 is 1. 2 divided by 1 is 2. 2 times 2 is 4. Right, so this is gonna be equal to 3 minus 1 plus 4, that's 3 all over 2. So of course, you know, this is reciprocal. Okay, this is something as 3 times 2. Okay, reciprocal, then 2 comes up, then 3 remain. So 3 cancels 3. Okay, so that's gonna be m is what, 3. Okay, so let's go now and get our equation. So equation is gonna be equal to y is equal to 3, right, into x minus x1, which of course is minus 2, right? Are we good? Then plus y1, which of course is 1. Okay, so we can simplify this. Okay, we can simplify this. So we now have y equal to, of course, so there's gonna be 3 into, this is plus, right? 3 into x. Okay, then 3 into 3 times plus 2 is plus 6. Okay, then plus 1. Okay, so y is gonna be equal to 3x plus 7. So you can bring it to this side. That's y minus 3x minus 7 is equal to 0. So as simple as that. Okay, okay, so let's proceed. Okay, so let's proceed. Let's get another question. Okay, so here's another question that we need to work on. Okay, I work on this question. Okay, it goes like this. The midpoint PSY and q 8,6. Okay, find sy if the midpoint is 5, so the midpoint, okay, is given as 5, 8. Okay, so the initial point, remember, according to this, okay, midpoint is always given as s1 plus s2, right, divided by 2, then y1 plus y2, okay, divided by 2. If that being the case, now in this case, now the initial s, the s1 is x and the y1 is y, and that's what we're looking for. Okay, so that means 5, 8, okay, it's going to be equal to x, right, plus x2, which is 8, divided by 2, comma, y1, which of course is y, that's what we're looking for, plus y2, 6, divided by 2. So now comparing this, okay, so that simply means that the x coordinates, s plus 8 all over 2, okay, is equal to 5. The same thing happened with y, okay, y plus 6 all over 2 is equal to 8. So you know what we do here, we cross multiply. S plus 8 definitely will give me 5 times 2, which is 10. Okay, so x now is going to be equal to 10 minus 8, which of course is 2. So for this, the same thing happens here. Y plus 6 across multiply gives me 16. So y is going to be equal to 16 minus 6, okay, which of course is 10. So that's how you solve that. Okay, so as simple as possible. So I'll give you the opportunity to go through all this. Okay, all right, see you in the next video.